Again, we have here a 3 terms recurrence, okay, with 2 initial conditions, and then this time is non-homogeneous because we have a term over there. So we have to proceed as usual. We have multiplied by Z2 n plus 2, right, which is the highest index. So we have this Zn plus 1, an plus 1, n plus 2, sorry, n plus 1 here, plus Zn plus 2 times an equal to 2 to the n Zn plus 2, right? And now we sum in the whole range. So we have the sum from 0 to infinity, Z to the n plus 2, an plus 2, minus 2 times the sum from 0 to infinity, Zn plus 2, an plus 1, plus the sum from 0 to infinity, Zn plus 2, an, and here we have the sum from 0 to infinity, 2 to the n, Z to the n plus 2, right? Okay, let's identify things here. Well, first we have to shift the index here, so we have the sum from 2 to infinity, Z to the n, an, minus, we take out one factor Z here, so we have 2Z, then we have n plus 1 and n plus 1 here, and that is the sum from 1 to infinity, Z to the n, an, plus, and we have a factor Z squared that you can take out, and then you have the sum from 0 to infinity, Z to the n, an, and that is equal to this. Again, there is a mismatch here in the exponents, but we can again take a factor Z squared, and that is the sum from 0 to infinity of 2 to the n Z to the n, or 2Z to the n. This is the geometric series, so this is equal to this. All right. As in the exercise, as in the previous exercise, this one here identifies with the function f, the generating function. Well, this is, by the way, the generating function, okay, directly. So this is the generating function with the 2 first terms missing. The first term is a0, so we have to subtract 1. And the second is a1z, so we have to subtract 2z here. This one here is just f minus the first term, the term n equal to 0, which is 1. All right? We now substitute this, and we get fz minus 1 minus 2z minus 2z fz plus 2z plus z squared fz equal to z squared over 1 minus 2z. Well, you can see here that these two terms cancel, right? And we can factor out 1 minus 2z plus z squared, right, times fz. So these 3 times here, this and this, okay? There's a 1 that we can put on the other side, so we have 1 plus z squared over 1 minus 2z, right? Which you can reduce to a common fraction by multiplying. So we have this over 1 minus 2z. And finally, you can see up here that this is just this binomial, 1 minus z squared, right, over 1 minus 2z. So the right-hand side is just equal to that. But also this factor here is 1 minus z squared, right? It's the expansion of this binomial. So this factor times f is equal to this factor times this. So f is simply this function, is 1 over 1 minus 2z. And the expansion of that is very easy because it's just geometric series. So this is the sum from 0 to infinity of 2 to the n z to the n, which means that the solution to our problem is an is equal to 2 to the n. That's it.